So I just wanted to give a quick refresher as where are we today? Radio Access Network is covering all the radio technologies for the wireless mobile communication since the start of 90s from GSM or what we call it 2G and then the 3G which offered more data services and the 4G which is very successful with all the mobile application to give a very good data connectivity or mobile broadband. And then there is 5G. Maybe it's not well in Egypt, but some other countries like Saudi, UAE, Qatar, Kuwait, and in Europe and US, it's quite dominant there. Now, this is, I think, most of us from the telecom are aware about it. I also give a small photo to say, to focus on this is a type of the radio access structure. You will find antennas or active antennas as in this one top here for 5G. And it provides a coverage or a radio signals in typically in three directions. And each site will have a multiple technologies from 2G, 3G, 4G, and 5G. And that's what we call it multi-radio access technologies, multi-rad, and multiple frequencies within each technology or share. The radio site in simple structure, and this is two pictures from two popular vendors, Nokia and Ericsson website, different formats, but it is one BBU. It's a proprietary device by each vendor, their own secret sauce and technologies and patents since long time. This connects to the same vendor radio unit, as you can see it on the tower, and to the same vendor network management system. So if you selected vendor A, let us say Ericsson or Nokia or Huawei, Samsung, ZTE, but you will have to buy these three components to serve the 2G, 3G, 4G, whatever technologies you are in a certain region or in the whole country. One word just to explain the single RAN, it means that multi-radio technology within the same unit. So the baseband unit and the radio unit can support 2G, 4G, and 5G on the same unit. And this is for some efficiency. Again, these are vendor locked because once you had a contract with vendor A, you need to buy everything. I try to give a very quick in 2 minutes what's the current situation today as 99% or 98% of how the radio access network works. One vendor provides a solution, and this solution is working with different technologies, and this is happening since the 90s. What happened is two phenomena. Radio market is not so profitable. It's high cost, and I will come to this later. But the rule in radio access network, it is a volume business and not a margin business, i.e. you make a very single digit margin, but with a volume you sustain your profitability. Okay?
Yeah.
Okay.
Then next, due to this, starting from the 90s, we used to have 10 to 12 radio access network vendors. Now, by the 2010, actually 15 was the last one, which was Alcatel-Lucent being acquired by Nokia. And the amount of key RAN players has shrunk to 4 maximum. So there is less options for the operators to buy from. Then there is political or security threats raised and concerns by US and the Western countries that there is a certain security threat from Chinese vendors, which means they need to stop using this equipment. And accordingly, it means that you are only left with 2 radio access network vendors. This is a duopoly, which cannot be tolerated by operators. On top of this, there was a lot of slowness, non-homogeneous. You cannot mix and match. This led for mobile operators to make and merge a couple of forums, which is the XRAN forum and the CRAN Alliance, into ORAN Alliance, which launched in 2018. And they said, okay, we are now the operators. We will try to create a place which will push the industry with some standards and guidelines for having a multi-vendor, a more openness based on on the 3GPP works. So most important point, the ORAN Alliance is a complementary with some specifications and standards and never contradicting or overlapping with 3GPP. 3GPP is the main standard body for the RAN access technology, and ORAN Alliance is trying to complement with some areas not specified in 3GPP. And the direction for them was mainly that we need more vendors, more innovation faster, more intelligence, and reducing the TCO or the cost of the radio access network. More than 30 operators are in this ORAN alliance, more than 250 plus from every vendor industry, from chipset, software, cloud stacks, ready units, you name it, you will find them there. And they start doing specifications or standards. So they came up that similar to the 3GPP, that there will be a 10 working groups to try to focus on a certain elements in the architecture. I will come to this later, but just when you hear the idea of work group 1 till 10, and there is 3 other parallel streams, the idea is considered as the like the RAN group 1 and till 4, or the core and CT or the SA in the 3GPP working groups, to set certain specifications or guidance on the architecture. Now, what is the architecture that ORAN Alliance is suggesting? ORAN is saying that we need to do decoupling, openness, and cloudification, similar to some extent from what was done in the core with the NFV, but we need to have a multi-vendor. We need to be ready for future intelligence and AI. So what they have done is 4 levels of disaggregation. If you remember at the beginning, we said till now, a baseband unit, which is the main hardware from each vendor, is a closed one, purpose-built specific hardware. They said, no, let us do like this. We will split this hardware with a normal COTS x86, for example, or AMD. Then second step, software itself will be virtualized, cloudified. The connection between the baseband unit and the ready unit will be open. So if I bring my pen, this is the second point here. Ready unit was from the same vendor, from the proprietary communication between the baseband unit and the ready unit. No. Second step of this aggregation, this open front hole will be a standardized interface with a certain format for this communication, and I can bring vendor A ready unit and vendor B CUDU and vendor C for the COTS server. So this is the second point. Third point, they said, okay, now the network management. Network management, we said it was from the same radio vendor. We said, now we try to make the management one management that manages all these multiple vendors. The COTS server, CUDU, the CAS or the cloud stack, the different radio units, the different regions of different vendors. And then we could have a third disaggregation. Then they said, okay, now let us also think about how we decouple from some features, which means that the control plane or the RAN features that a certain vendor is providing part of their software release, I can little bit interact with it via a new element, and that we call it RIC, RAN Intelligent Controller. And this is a completely new functionality or new box. And the idea is feature development or solutions be powered by AI and closed loop can be inserted inside the functionality of the RAN via this block. So 4 objectives they are trying: the disaggregation, the openness, the multi-vendor, and the cloudification. Now, what is the commercial hopes out of this? If the cloud make multiple vendors, the competition in terms of development and pricing will increase, and accordingly, they hope that TCO would decrease. Second, if we move towards cloudification, this means that I will benefit from the automation, the cloud economics, the agile methodologies, and this would accelerate the innovation, the time to service, and this will be much faster. And later on, it will open the door for the AI and machine learning implementation. So this is the main three areas: TCO, multi-vendor, innovation, and cloudification. Now, let us go one step. What is exactly the architecture, the reference architecture, same like, and you can think of it as like the HC NFV reference architecture. So we agreed the baseband unit with its software will be split into DU functional, distributed unit software functionality. The radio unit is still a physical radio active device. So considered as a physical function performing the RAN emission and reception. And it communicates via open interface, which was till today closed and proprietary. A second part of the software is the CU, centralized unit, a user plane and control plane. And if you remember when Karim 2 weeks ago spoke about cups, so it's the same again, same concept, splitting the user plane and the control plane into two different entities. And you can say that all this was the baseband unit and the radio unit combined into two physical boxes in the current traditional RAN solution. Now we are disaggregating that. The OCloud here refers to the cloud stack and the hardware running this x86 and the OS, the cars, and all the related functionalities. Now, management. So we will have a new concept framework called service management and orchestration framework. And simply it should do the network orchestration for the functions, because this will be again, hopefully from the direction of the ORAN, that it should be a cloudified functions, CNFs, for the DU, for the cloud stack, for the CU, and for the RIC, which we will talk more about it later. So there are several software functions, need orchestration, need the FCAPS functionality, and then they said, okay, what about the intelligence and programmability? Where we will put it? They created this non-real-time RIC box and near real-time RIC box. And RAN intelligent controls, the whole idea is, think of it as a platform that interacts with the radio functions, the CU and the DU, via defined interfaces of the E2 and the O1 to get certain information, configuration management, a simple and call trace, performance data, like cell counters, alarms. And then we'll expose this to a certain algorithm from a third party developing, like the app, similar to the mobile apps. And this app will do energy saving. So nowadays, if what's happening in the current RAN vendors, each vendor within the software has their application features, software features with many of parameters. It can be thousands actually in 4G and multiple thousands in 5G of setting the configuration of the radio cell, starting from the cell ID till all the RAN management and scheduling and handovers and whatever. And it works in a very complex way. Part of this is what we call it the NRM network resource model, is based on 3GPPs, and each vendor adds their own parameterization. What the RIC is trying to say, look, I will read this data and share it towards an algorithm. Algorithm will say, okay, if cell A and is less utilized, like the PRP utilization is 10% and cell B is 60%, I can ask the user to do inter-cell um, interfrequency handover to the second cell, and then cell A is now 0, I can switch it off. This one simple example is existing as a feature in each of the proprietary vendors. But now I can do this in the RIC, and then in the near future, I will use machine learning to make training of data. So I can, even based on the specific network behavior, I can do more difficult um, functionalities about the MIMO, multi-user MIMO, massive MIMO, CSI. If you know all these parameters in the RF interface, I can use machine learning to take a decision, very good uh, settings for the optimization of the network based on the network behavior, and do not rely on the current vendor-specific feature, which is static. Second, this will create a uniform performance across all the region. One of the challenges in multi-vendor networks that in region A, you have vendor A with their own settings, region B is vendor B, and you cannot have 100% uniform parameter settings. But if you are doing this from a higher layer, multi-vendor, you can have a uniform network strategy and optimized for the performance till it, and the future is we can tune till the user level service monitoring and adaptation. This is in high level. Now, this is a reference architecture. Defining interface points was not mentioned before. Multi-vendor operation, multi-vendor cloud stack with their own hardware and software, multi-vendor ready unit, and baseband unit software, all cloudified. At the same time, the standard 3GPP interfaces, the X2, the NGU, the XN, are not touched, but complemented with E2 interface, A1 for the operate FCAPS, O2 for the cloud infrastructure management. And for the RIC, there is a specific interface between near real time and non-real time called A1. So you may ask, what's the difference between this and that? Radio has a lot of functionalities. Something like, for example, radio resource management happens in milliseconds. And if sometimes we need to do scheduling or the radio resource functions, it need to happen in this range as a decision in the millisecond. So for functionalities related or decisions in a very short time, maximum 1 second, it will be done via near real-time RIC with an X app running on top of it. If it's a long-term process, like something changes after 1 hour or every couple of days, or based on a long-term data inferences after machine learning workflow is complete and ready, then it will be done via an R app running on non-real-time RIC. I will pause here because I think I spoke a lot, and maybe it's time for some questions.
Yes, Sherif, I have one.
Yes, please.
Okay, so actually two. The first one is basic one. You mentioned that the interface between the RU and DU now it's like started to be somehow open. The what they call the
Front hole.
open front hole. Yes, exactly. So I'm asking about the former eCPRI. I'm not a radio guy, but I've seen many documentation and many old documents referring to some sort of attempts to do standardization of the eCPRI. But most of radio professionals, they say that that was proprietary interface. So I'm not sure, was it proprietary or it is standard, but no one adopted the standard maybe.
Okay, so it's a good question, and there is how it moved. Now, first part, most till 4G and few parts of the 5G are CPRI, not eCPRI. And CPRI is completely closed and static. Then what happened with 5G massive MIMO? The communication between the baseband unit and the radio unit, this front hole, was so huge. We're speaking about several gig and in 64T, 64R massive MIMO, it can reach to a couple of hundred gigabit per second. So one way to optimize that was to use the eCPRI protocol. Then now, so eCPRI is more open. It's not as a standard itself. It's not a vendor specific. But the communication, what type of data is over baseband unit to radio unit, the management in plane, like how I do the management or the O&M of this radio unit. So what syntax of format? Ericsson will have its own language. Nokia will have its own language. Huawei, ZTE, everyone will have their own language based on the previous history. Then the data is data. User plane is clean, but again, how you will exactly do the coding and when exactly each vendor has their own secret sauce. And that's why you say, like, I am better in the uplink. Some other vendors say, I am better in the downlink because of the technicalities of this. And this, and then you have the control plane, how the configuration. So eCPRI as a protocol is a standard protocol. Then how the data formatting and the procedures of activating and communicating and setting up the link of the open front hole needs someone to define it. 3GPP didn't define it. They gave some hints what should be done as an end. And for sure, because 3GPP is dominated by vendors, so they didn't want this to be open. And this is a killer. If you put yourself in the CFO of any of these RAN vendors, you will agree that it's against their business and growth. But industry want to little bit change that. I hope I answered.
Yeah, you did.
Now,
thank you, Sherif.
just to be aware, all these standards in open front hole, which is part of work group 4. We mentioned that there are 10 working group. So work group 4 is focusing on this open front hole specification and the famous name 7.2x split. And in 3GPP, there was something called functional split. And the communication of the front hole, they selected the 7.2x, which was very matching with the eCPRI way. However, because again, devil lie in details, now we have till 2 years, we had two flavors, A and B. Now we have, with the B uplink performance in the improvement, A and B again. So now we have 4 variants. And to fragment or to some, in other words, to little bit from some big vendor to make things not achievable or not successful. So this was your
I can
first.
imagine. Yeah.
So what's the second question?
My second question about the market products, especially about the orchestration or the near real-time break and the non-real-time break. The products are usually are splitted, or some vendors are offering two in one functionality. Who is actually providing this kind of solutions in the market?
Okay, I will touch this. I have one public slide, all the players in each segment, but
Okay, cool.
usually these are two separate products, and some vendors provide both. Some vendors select near real-time break and focus on that, and or non-real-time break and focus on that. However, till now, from maturity level, the activity is still in the very early phase, but the number of POCs and successful POCs, significant or relevant POCs, are much more in the non-real time due to the need for interfaces not supported by all the vendors yet. Unlike 3GPP, where release 14, you have a compliance. 15, I need to be a 5G RAN vendor. I need to comply to 60 or 70% of that. In ORAN, still, we are in like release 3. Things not 100% clear. Things still are to be decided. Things are still in debate. Few things are little defined.
Thank
Now,
you, Sherif.
Sherif, I have just questions.
yes, please.
Quick ones. For the front hole, do you see like adoption in the market for the front hole? The second question is do we have any intelligence in the RU when it comes to 5G, or is it still the same like 3G, 4G, whatever?
Okay, so I will answer second question first. For the radio unit, ORAN Alliance do not modify what 3GPP. So radio unit based on the 3GPP specification, layer 1, layer 2, layer 3. What ORAN is adding is saying there is a communication front hole towards the baseband unit or the DU. You need to make the implementation and the communication in this format and this bit or frame structure, so the communication and procedure are multi-vendor. This is one. Now, intelligence, if you are speaking about uh, AI machine learning, it's too early to say that there is machine learning implementation in the read unit itself. It's something maybe in 6G. But ready unit is with the 5G, uh, with the AAU, it's quite complex. It's quite advanced compared to the basic ready unit FDD in the 2T, 2R, or 4T, 4R in the 4G. It's more complex because of the massive MIMO and all the related. You will use a grid of beams. You will using zero. How you frame massive MIMO and the beamforming is a session we can talk 2 hours about it, but there are many technologies out of that are using CSI, RS, or this type of how you do the beamforming is complex. First question about what's happening in the market now. So yes, there are vendors. I'm not sure shall we mention names or no, but this is public, like the press releases say that, okay, like in Vodafone, they make a press release saying that we brought a RAN solution from Samsung. We had some Samsung radios and we had NEC radios. In Dish Network, they said we had 2 RAN vendors and we had couple of radio unit vendors, not only A and B. In Japan, the same. In Germany, yeah, this week there was announcement from the Telefonica Germany about a similar uh, cloudification. In US, there is some AT&T claims that they are having biggest ORAN network to start to deploy. However, critics, and I leave you to read LinkedIn, are criticizing this, that it should not be mentioned as ORAN at all. Any further question?
My question was about front hole specifically, not the ORAN. So do you see adoption? Because what I heard is it's not moving. Then I see vendors still pushing. So I don't know.
Yes, front hole. Yes, the idea of front hole is if I follow the ORAN Alliance Work Group for open front hole implementation, I can be vendor, let us say, according to the press release, Samsung DU connected to NEC radio unit based on the open front hole interface specification. Without this, they cannot.
Okay, thanks, Sherif.
So it's happening, but few vendors are allowing that. Now, yes.
Sherif, yes,
what's the difference between the M plane? What is the M plane? For
M plane,
yes,
the management of the radio unit. So radio unit is a function. It has alarms, it has failures, it has DH need an IP address, it has a certificate for authorization or and authentication once it connected. So all this data is done via the M plane. And if you notice this CUS control, user plane, synchronization, management, were all hidden with a proprietary protocol from each vendor. Now, ORAN is trying to say, okay, let us split so it can be clear how to managed. So this data in plane should go to the FCAPS functionality in the SMO. However, control is a communication for the setup and the frame protocol for the between DU and RU. And maybe later, or if you went to the work group 6 and work group 4, you will see the eCPRI and the frame structure to get more details about it.
Great. And here there is one block called O E node B. This means that it's another E node B, because what I understand is all of this is part of the open E node B, right?
Okay, it's a good question. So now, ORAN Alliance said that they will focus their specification on the 4G technology and the 5G technology. So whenever the letter O, it means that this function or this node or this device or this piece of software is ORAN compliant. So we call it O E node B for the 4G. So in the 4G, there is no split between DU CU because the 3GPP release 14 functional split was mainly for 5G, not for 4G specifically. So to simplify things and not reinvent the wheel for 4G existing, we keep it as E node B. For 5G, the G node B, instead of saying OG node B, we say ODU, ORU, OCU. That's it.
Great. Thanks, Sherif. Thank you.
Karim, I think you
Sherif,
wanted
yes. Do you see the chat, or shall I read to you the question?
just 1 second. Let me open it.
So the question about the new players in the hardware domain, like does this open the door for new players and like low cost hardware? And also another question, like who will manage this hardware? I think maybe this question about who the team or internally, will this be the radio team, will be the cloud team?
Exactly. This is a real great question that I wanted to discuss in the ecosystem. But
Yes.
maybe if you give me 5 to 10 minutes, if it's okay, when I show
Sure.
this ecosystem slide and we discuss what's the challenges and the reality.
Yeah, sure.
Now, so if you can see this in the upper diagram, AUE and 4G or 5G ready unit connected to the vendor specific, all closed. However, here you will have a multiple open and mainly in this point by 3GPP, but also in this management point here. Just for sake of names, so we can say classical RAN, traditional RAN, single RAN, all are in this criteria. It is a vendor-specific solution based on 3GPP, compliant with 3GPP as far as possible, and this is 98% of all the radio access network deployed today. ORAN deployment is very little, and I will touch on that later. ORAN is a name or a term, and as you can see, O-RAN, it means that this is a solution based on the ORAN Alliance standards and compliant with it. One example is Dish Network in US, 5G, Rakuten 5G network. Some of the POCs, some, not all of the POCs happening here and there. And this takes us to another name, vRAN or Cloud RAN. So Cloud RAN is a cloudified radio access network based on the cloud architecture, taking some parts from the ORAN Alliance in the cloud stack, but not open interface, i.e., I will provide a solution from my radio unit, my CU, my DU, my network management system. I will not open the AO1 interface, the A1 interface, the E2 interface, but I will run this on x86 from any vendor on a cloud stack, either from home or from any cloud provider. Say it is Red Hat, say it's Wind River, say it is VMware, say it is other hyperscaler. So it's important to just take, because analysts sometimes or press release can be confusing here, but really focus, is it ORAN or is it vRAN or Cloud RAN or both? Then Open RAN like this, it was part of a stream project in a TIP, telecom infra project, to have a multiple openness and a certain interface point, especially on the front hall and the cars. Actually, it was virtualized, so it was VNFs for 2G, 3G, and some extent 5G. Some of this work on the tip has been readjusted because they joined hands with the ORAN Alliance. Also, by the way, ORAN Alliance and 3GPP had some memorandum of understanding to join forces or some sort of avoid any uh, overlaps and also accelerate specification. Similarly, ORAN Alliance also had memorandum of understanding with the Linux Foundation. Now, I touched about the vRAN, Cloud RAN, Open RAN. This is, and thanks for Nokia, it's developed by Nokia. So you can have an ORAN compliant solution, but it's not cloudified. So you will get the baseband unit, famous and successful AirScale from Nokia, or the 6000 series from Ericsson, and you say eCPRI and open the eCPRI according to 7.2x standards from ORAN Alliance for Group 4. This could be called as O GNOP. Or you can say, I will replace this part and make it cloudified, VDU, VCU on a cloud stack. And here it is ORAN and also cloudified or virtualized. So both together. And that sometimes they call it horizontal split and vertical split. I see one question. I prefer to consider. Carlo, the point is nowadays there was only few vendors who provided the RAN function as virtualized in VNF. Now, most of the work nowadays are about being containerized, and then using the cloud stack, and that's where they start to say Cloud RAN and rather try to drop the word vRAN. But the terms are a little bit, sometimes you'll find some press release that or saying a vRAN, but actually it's based on the containerization and cloud stack, but maybe the author of this press release wrote vRAN. So I shared with you the definitions, so you can be very what each term should mean and should not mean. Now we spoke about ORAN, and I'm trying to get back to the main discussion of this program, which is the telco cloud. So we spoke about the RAN and a lot of details, but how cloud RAN, and is it based on closed interfaces or cloud RAN with open interfaces, according to all the work groups of the ORAN Alliance, differs from the telco cloud functions in the core IMS, VEPC, and now in the 5G standalone core, and some of that were explained by Karim last sessions. Always, like, I'm a radio guy, so I'm a little bit biased here. We always say in the RAN, RAN is completely different, and who do not understand the RAN cannot understand the complexity of the RAN. Our colleagues in the core will say the same core is very complex. Who didn't work in the core and coming will think that it's very simple. And similarly, also in the telco cloud and the cloud stack, so every system has its own complexity. The problem here, the RAN was closed on itself. There is a defined 3GP interface, and after that, everything is completely closed with the vendor. Now we need to cloudify it and disaggregate. But what is the uniqueness in the RAN? You will find the number of sites. So a typical country like Egypt will have more than 10,000 sites plus minus. In Europe, it's very normal to find 20,000 cell site, as I showed you in this tower, where you have the baseband units and the multiple of radio units, multiple of baseband boxes. In US, I can speak about hundreds of thousands. In China, for example, it's millions. So the geography has, because again, each cell site, G node B, E node B, need to cover a certain geography of a couple of hundred, maximum 1 kilo on the, or a couple of kilos on the highways. That's it. So you need to, so you will have thousands, which means thousands of server. A network estimated, like if we say that a network of 10,000 radio network sites would need around 25,000 COTS server. Now, Karim, if I asked you in with your work without any name, what's a typical data center for telco cloud? How many COTS server you will have? Hundreds?
No, even less than that. One data center.
I will say for
Less than that.
geo-redundancy and all this geographical distribution, okay, maximum 300 COTS server in the whole country in one operator, OSS, BSS, and
maximum,
core function. Maximum. Now we are speaking about thousands, and this is like just the starting, like phase 1 and 2, and so the scale is huge. And here, without automation, it will never succeed. Second, location. The data center is one place, secured, cooled, electricity is there, so you don't need any the outdoor. If you are familiar with the RAN, there's something called the IP compliances, the IP55, IP65. So all this environmental requirement, like ruggedized servers that will be deployed in the cell site, will not enjoy high air condition, AC. No, it will be DC. It will be fan cooled. It need to be have a lot of heat sinks to release the temperature. So a lot of physical uh, restriction and constraints completely different from how it works in the data center. Then all this is the physical part. Then we move to software. The radio, if you I mentioned that it's by frames. So the TTI is 1 millisecond, but within the TTI we have how many bits. So we are speaking about the microsecond. And according to 3GPP, timing accuracy should be plus minus 1.5 microsecond on the radio unit arc, which means that if I cannot tolerate that, yeah, it's 1 millisecond delay, or you cannot do that. It will not work. Second, amount of throughput is huge. It little bit resembles what's in UPF. It little bit resembles in the security gateways to some extent. I'm not expert in this area, but from complexity, but this will have to repeat in every site. Then now performance. This means that you need to have many new things was not common. So for example, DPDK or SRV, the virtualization transport or networking virtualization for high throughput was there in the telco cloud for the core functions, but now we are speaking also about CPU pinning as must because of the TU. We are speaking about something called accelerators, that there are certain parts in the layer 1 of the RAN stack cannot be done with the normal CPUs. We need a dedicated GPU. We call it the accelerator to do this forward error correction and channel coding. So there's a lot of burden and adjustment. So it means it, and then also you will need PTP or timing synchronization. You will need the kernel in the operating system need to be real time, which means that it has a deterministic, defined, and minimal latency and delay. So all this is not common in the telco cloud deploy. Any question here or any points you would like to add, Karim?
Yeah, actually, you brought a very interesting topic, Sherif, and this is very aligned with many of the reflection that we had in the program, because the colleagues were asking about a practical use case. So now you brought the challenges. I think this may shape the next or the after next the session maybe we can present how actually the cloud is trying to cover or support these requirements. So it's a lot of pressure on cloud, I would say, because here the latency requirements and even the features are very aggressive, and the footprint is very low, and even the CPU requirements on the edge or on the ORAN side is not like the core side. So it's a really a challenging situation. So
Exactly.
that can open, yeah, that can open the door for a very interesting topic about how cloud adapts to these requirements. So thanks, Sherif, for bringing that.
Now, Muhammad Shabo, I think I didn't get your question about the codes. So what?
What I meant to say, in the core, we kept hearing that from the server there will be COTS. It's very easy to find, it's more available, it's low cost. But the
Yes.
reality till today, this hasn't been the case. Till today, there are only few suppliers for these COTS, and they are not cheap at all. So with the
Yes.
more requirement that you mentioned in the RAN, I guess this would become even more difficult to achieve, which means the terminology COTS,
Yes.
it's not yet achieved.
Okay. So the terminology codes server, or the beauty of it or the value of it is not achieved. Yes. And in the challenges, this is one reason the TCO of the cloud RAN is higher than the traditional RAN, which is completely against the whole idea of the ORAN Alliance. We reduce the TCO. But you are right. However, there is one aspect which is the computational improvement. I don't want to all the like AMD, ARM, Intel with the new generation of servers, sockets like the CPUs are providing more computational efficiency to reduce little bit of the cost. But let us see. Now,
Sherif, can I just
yes,
comment on this one, even for all the colleagues to understand the concept? So Muhammad Shabo was saying that we have always heard the term COTS whenever we were talking about the cloud in the core or the private cloud in telcos in general. And you know, COTS by definition is the abbreviation for the commercial of the shelf. So it gives the impression that you can just go to any hypermarket, get the server from the shelf, put it into action. But what we are seeing that the use cases or the application or RAN code, they really require very aggressive requirements when it comes to hardware and to specs of hardware and software. So the COTS itself, the term, how much I will believe that it's not the right term to be used, because this is not just a COTS, it's a very specialized hardware. And then Sherif, you said, and maybe this is one of the challenges or to realize or to bring the value of the ORAN use case, that what we see now is even the TCO, total cost of ownership of the ORAN, because of using this specialized infrastructure, may even exceed the former traditional radio setup. And that negates the whole thing, because as you explained in the first slide, the motivation was to lower the TCO. So yeah, it's kind of a loop of challenges, a circle of challenges.
exactly, Karim. Now, one last part is the SMO, and you hear, and there is more of traction or hype about the SMO. So it was one part of the architecture of the ORAN Alliance, which should cover three functions: the orchestration of the CNFs, the management of the cloud, the management of the RAN, and the non-real-time rig. So actually, if you are aware what's happening now, we have the radio, the network management system, say it is E&M, say it's NetAct, say it's M3000, say it's USM. All the vendor has their own network management system managing this radio unit, this baseband unit, and the software. Great. And then you have also a system, uh, northbound interface, and then you have some other analytics and planning tool. And I'm sure you are familiar, the radio guys are familiar with the term of CSON. So it's self-organizing network, which came with the 3GPP, starting from release 9 and keep improving to do certain analytics on the radio access network. Now, these are vendor specific, and some cases it can be multi-vendor based on the OSSI open initiative. However, reality it's this vertical closed. What they are trying to evolve with the ORAN Alliance that, okay, fine, I will have the radio running on O cloud. So same like we have a cloud, but now it's ORAN compliant, so we'll name it O cloud. And there is an EMS, fine, and there is a radio network function. And then I will interface this EMS with the SMO. So they will collect the O and M, but they will provide network function management for the CNFs. They will provide cloud management, like federated O cloud management or the FOCOM. And then I will have the R apps doing some intelligence. Think of it as a sort of a new functionality or feature for increasing throughput, increasing the massive MIMO utilization, certain reducing the ping pong handovers based on the data collected from the EMS and given to the non-real-time rig, and the non-real-time rig is coordinating this between the R app and the net. And like as if this is the guy who translates and manages all this idea. And then insert the new configuration parameter or command to the EMS. Then they said, okay, the final open RAN as full SMO should be that I will have no EMS. I will have the function, the radio access network function CU, DU, or O E not B, will have an interface called O1 interface, open based on the ORAN Alliance. So part of it in work group 1 and part of it in work group 10. Communicate and provide the network function and fault management, all the FCAPs, fault, configuration management, performance management, security, all and accounting, all this will be from the direct based on the O1 interface standard. And the R apps will continue working, and that will be, and the cloud will provide sort of O2 interface, like the CAS layer, and the servers will also comply with an O2 for sharing their FCAPs. And the future NMS will be SMO based combining the orchestration functionality, the FCAPs functionality, the intelligence with non-real-time rig, and opening the door for many features. So let us say, and it's not let us, it's actually a couple of operators now, and have from the optimization team, after many years of working, they develop a certain say, look, this is our way of setting the thresholds. This is our way of setting the margins in the for the handovers, for the layering, for the traffic strategy. Actually, if we have certain error, we will do that. If we have certain, they have certain blueprint of after many years in understanding the geography, the propagation, and the technology of the vendor. Now they are coming and saying, okay, I will move this knowledge into a certain application here, and instead of the optimizer creating the XML changes and sending it to the operation team or executing it, the R app, in-house R app, operator in-house knowledge will do this. They know which CM parameters to change at which PM, like KPIs threshold, they should do this change. This will be automated. And then machine learning, when it comes that we collect data, we do model tuning, and then use the new set of data to get inferences, and then from inferences with some static information, we do a decision outcome. This is a new game with the term AI for RAN, but this is the overall SMO concept. Any question here?
Sherif, we may have like another 10 minutes. Just
okay, I will stop.
Heads up.
So,
is this the last slide?
yeah, last slide is this ecosystem where we want to.
Can you just go for this one? Because I think it's interesting for most of
Yes.
the attendees.
Now, we mentioned that it opens the door for everyone to enter the game. And you will find that code server, there is many came from the edge business. From the cloud, as I said, there are many cloud software providers. Transmission is still transmission, so I would ORAN does not touch it. Processors and the main players. However, the accelerator, if you remember, I told you in layer one, there is one functionality needs GPUs or DPUs, not CPU, to do this functionality. And there where we'll, if you heard the term acceleration and inline and look aside, the big debate in the industry now. So many have came like Marvell, Qualcomm, NVIDIA for sure trying to insert themselves. Then we move to another important part. Who will cook all this mix? Now there is the system integrator. Before we used to sign a deal with a vendor, and the vendor will drive whole equipment, solution, tested, ready, even offer the implementation services, care like support, software support, software maintenance, and now we're speaking even about managed services. Now it's multiple components, multiple vendors, so you need someone. So there was the rise of system integrator. However, let me tell you, reality till now, operator are saying that the RAN vendor would be the best one to be the SI from history and from majority of the scope. And this guy, one of these guys in these boxes, like the Mavenir, the Samsung, the Nokia, the Ericsson, if we would like to consider them, will manage everyone else from the cloud, from the servers, from the services, whatever. Then we have a new need for testing. Radios, there are new vendors that use to develop small amount of radios and sell it. So OEM, now they are trying to enter the market alone because they don't have CU, DU, or anything else, just they have the physical radio unit. So it's a new arena. Now, reality is operationally, we have three nationwide networks, one in Japan, with Rakuten, in US, huge, 21,000 plus dish. There is Eins und Eins in Germany, but it's very slow, still not. But all the others are trying to do one site, two sites, three sites. Vodafone is making a major RFP and announcement every now and then. Telefonica also is making a lot of announcements. Others are a little bit small cluster, 7 sites, 4 sites, and that's it. Which will lead to another part, the complexity of this and the higher TCO, making it slow to progress for the operators, and the maturity of the cloud and the technology itself and the knowledge. So we don't see thousands and thousands of swaps and deployment. Unfortunately, and thanks, by the way, this slide was prepared by Mavenir, and as you can see, it's version 13. And unfortunately, next year, ربنا يديكم الصحة والعمر إن شاء الله, will come and we'll see that it's halved. Not everyone will be able to continue because there's no much money for everyone. I think let's stop here.
Yeah. Sherif, really thanks a lot for the presentation and the explanation. It's really wonderful, and in like 15 minutes you grouped a lot of information. For me, that's the ideal base and foundation for anyone who wants to understand the evolution of the OpenRAN. And also thanks because you kind of implicitly defined the scope or the presentation or the content of the next session. So I would like to work on based on the info that you provided, and we complete the whole picture for all the colleagues to understand the end-to-end picture from the RAN to the cloud. So I'll be working on the cloud part, maybe present, and even we can cooperate together how the cloud, I would say, fulfill the promise or the requirements for the ORAN. I just want to see if there are any other questions that we missed. No. So let me stop the recording and then we can take like some friendly discussion for the next session.